Hey guys, this is Mrs. Keith, and today we're going to learn about how to prove that lines are parallel if you know something about the angles. So we're doing the converse of the theorems that we learned last class. So this first section is kind of telling you exactly the converse of the theorems you learned last class. It says complete the postulates and theorems that begin with the statement, if two lines are cut by a transversal so that a pair of corresponding angles are congruent, then you know that the lines are parallel. So last class, we were told that the lines were parallel, and that meant that the corresponding angles are congruent. This class, we're going to know that the corresponding angles are congruent, so we know the lines are parallel. So remember when we had a set of parallel lines, remember these arrows mean the lines are parallel. This dot here and this dot here represent corresponding angles. They're gonna, if we know that they are congruent to each other, then we know for sure those lines are parallel. All right, so the next thing says if two lines are cut by a transversal so that a pair of alternate interior angles are congruent, then we know the lines are parallel. Okay, so this would be an alternate interior angle with this one, or these would be alternate interior angles. All right, if you know a pair of alternate exterior angles are congruent, then you know that the lines are parallel. Okay, so this would be an alternate exterior angle with that one. Or this one up here on the top left will be one with this one right here. If you know that same side or consecutive interior angles are supplementary, then you know that the lines are parallel. All right, these are considered the converse theorems because they're the flip of what we learned last class. Remember over here from this table, if you have the same shape, like if they're all dots, then they're all X's, then they're congruent to each other. If there are different shapes, then they're going to be supplementary. So just a reminder of how to figure out if it's supposed to be supplementary or congruent. All right, let's move on. All right, using those converse theorems, we're going to look at the information they give us and determine if we can figure out if the lines are parallel or not. If they are, then you're going to name the postulate or theorem to justify your answer. So we've got two sets of lines. We've either got lines A and B that might be parallel, or we have lines X and Y that may be parallel. Remember that like all of these angles right here have a relationship with each other. All of these angles right here have a relationship with each other. Those are angles that are either formed by, in fact, let me go back. These angles I've have highlighted in green right here. They're angles formed by lines X and Y and transversal A, and they have a relationship with each other. If you look at these angles right here, these are angles formed by lines X and Y and transversal B, so they have a relationship with each other. If you look at these angles, they're formed by lines A and B and transversal X, and they have a relationship with each other. And then if you look at these angles right here, they're formed again by lines A and B but transversal Y, and they have a relationship with each other. Otherwise, if they're not in a circled group, they don't have a relationship with each other. Okay, so let's see what we have learned or what we can use here. We're going to talk about angle 7 is congruent to angle 11. So that's part of this group right here. And those are alternate interior angles. They are formed by these parallel lines right here and this transversal. So as long as we know alternate interior angles are congruent, we know lines A and B are going to be parallel to each other. So that's what I'm going to say here. I'm going to say A is parallel to B, and I'm using the fact that alternate interior angles are congruent. Okay, let's move on. Let me erase all that, sorry. Okay, so next we have angles 4 and 9. So angle 4 is congruent to angle 9. Those are going to be formed by these parallel lines, or these lines here, and these transversals, or this transversal. As long as you know that we've got those are corresponding angles, as long as we know that corresponding angles are congruent, then we know that the lines are parallel. And the two lines in this case that are going to be parallel to each other are x and y. So x is parallel to y, and it's because corresponding angles are congruent. All right, next, let me erase all that. Okay, we're going to talk about angles 9 and 11. Okay, 9 and 11 are formed by these lines and this transversal. Now those are same side interior angles. And same side interior angles are supposed to be supplementary. This is telling me that they're congruent. So I wouldn't be able to determine if lines are parallel or not unless they were supplementary if they're same side interior angles. So we would say none here. And I'm just going to say same side interior angles should be supplementary. Okay, next, let me erase all of this. Sorry, I'm probably wasting your time with the erasing. Okay, next we have angles 6 and 5. 6 and 5 are formed by this line and this line. It's not formed by 3 different lines. You don't have 2 possible parallel lines in a transversal. These are considered vertical angles, and vertical angles are always congruent. They won't determine if lines are parallel or not. So we would say we don't know if any lines are parallel here because vertical angles are always congruent. I'm going to write they are always congruent. They don't determine if lines are parallel. I just use the parallel line symbol there. All right, next, let's see. All right, we've got measure of angle 6 is 70 degrees, and we've got the measure of angle 4 is 110 degrees. All right, those angles are formed by these 2 lines and this transversal. And if you'll notice, this angle and this angle, those are same side interior angles between lines A and B. And same side interior angles should be supplementary. 110 plus 70 is 180, so they are. So we would know that lines A and B are parallel, and it's because same side interior angles are supplementary. All right, let's move on to the next part. Okay, we're going to do basically the same thing again. We're just doing a different picture. So you may want to pause it and see if you can get the right answers and then check your answers with me. I'm going to walk you through it just to make sure. We've got angle 2 congruent to angle 7. Those are formed by these lines and this transversal. So that tells me that those are alternate interior angles. And those are alternate interior angles are congruent. Therefore, I know that lines K and F are parallel to each other. All right, next, I've got that angle 6 and angle 14 are congruent to each other. Those are angles formed by these lines and this transversal. Those are then corresponding angles. And corresponding angles, if they are congruent, then you know lines are parallel. So the 2 lines that would be parallel here are W and H. All right, next. Okay, so we've got angle 5 and angle 9. Those are same side interior angles that are formed by these lines and this transversal. Same side interior angles should be supplementary. So we don't know if anything is parallel here. I'm going to say here, same side interior angles should be supplementary. All right. Okay, next we've got angle 2 is congruent to angle 12. Well, if we're going to have the relationship like we should with either alternate interior or same side interior or corresponding or any of those, the angles have to be formed by the same set of lines and the same transversal. So both of those angles are formed by lines W and H, but angle 2 is formed by this transversal. Angle 12 is formed by this transversal. So they're not formed by the same transversal. So they're not any of those types of angles we've been talking about. So we would say none here. Okay, next we've got angle 3 is congruent to angle 10. Okay, those two angles are formed by these two lines. But again, they're formed by different transversals. Angle 10 is formed by this transversal with line H. And then angle 3 is formed by line W and this transversal. So they don't have a relationship. They're not alternate interior. They're not corresponding. They're not same side interior. There's no relationship with those angles. So we would say none. We just don't know because they're not one of those special angles. Okay, next we've got angle 6 and angle 10. They're supplementary to each other. Well, those are angles formed by these two lines and this transversal. So same set of lines and the same transversal. And those are same side interior angles. So they should be supplementary. So same side interior angles are supplementary. That means that W is parallel to H. Okay, now we've got that angle 8 supplements angle 12. And those angles are formed by lines W and H and this transversal F. So they definitely have a relationship with each other. They're same side interior angles, so they should be supplementary. So again, we know something because we have same side interior angles are supplementary, and what we know is that W again is parallel to H. All right, lastly, we're talking about angle 12 and 13 being congruent to each other. Those are angles formed by these two lines and this transversal. So if you'll notice, those are alternate exterior angles, and that makes, as long as those angles are congruent, that makes lines K and F parallel to each other. All right, let's move on to some proofs. Okay, so we've been given this picture, and we were told that line A is parallel to line B. So I'm going to mark that in my picture with those arrows to show that they're parallel to each other. We're also told that angle 6 is congruent to angle 11. Now, those aren't angles that have a relationship with each other. Remember, 6 has a relationship with these angles, and it has a relationship with these angles. 11 has a relationship with these angles, or it has a relationship with these angles. But 6 and 11 don't have a relationship with each other. So we're going to do some extra work here in order to prove that lines K and M are parallel to each other. All right, so let's just think about what would be helpful. We could think about knowing the fact, and I'm going to highlight this, knowing the fact that these two lines are parallel to each other. I could form a relationship with 6 and some angle, knowing that those two lines are parallel. So if those lines are parallel, we know alternate interior angles are congruent. I'm going to mark that here. Alternate interior angles are congruent. I also know that corresponding angles are congruent. I also know, saying things like same side interior angles are supplementary, but I'm talking about congruency here, so I probably want to focus on that. So I need to think about what would be an angle that angle 6 is either an alternate interior angle with or a corresponding angle with. Either one of those works just fine. 6 and 15 are alternate interior angles. So that's what I'm going to say next. Angle 6 is congruent to angle 15, and that's because if you have, let's see, if A is parallel to B, then alternate interior angles are congruent. All right, so next, I can now relate 15 and 11. I mean, I know if 6 is congruent to 15, then 15 also has to be congruent to 11. So I'm going to say that right now. Angle 11 is congruent to angle 15, and that's using our transitive property. Basically, if you've got angle 6 congruent to angle 11 and angle 6 congruent to angle 15, then those two angles are going to be congruent to each other. That's what the transitive property says. Okay, step 4. Now that we know angles 11 and 15 are congruent to each other, now I can say that K is parallel to M, and I'm using the converse of the alternate interior angles, or I'm sorry, the corresponding angle theorem there. So if corresponding angles are congruent, then the lines are parallel. And you can just say converse of the corresponding angles theorem, if you'd rather. I just wanted to write it out for you. Okay, let's do another one. All right, on this one, we've been given that K is parallel to M. I'm going to mark that by highlighting them. K and M are parallel to each other. And we're also told that 6 and 12, this angle and this angle, are supplementary to each other. Well, those angles have no relationship to each other, so we can't really use something like same side interior angles or supplementary. So we're going to have to work a little bit harder. I do know that angle 6, and because lines K and M are parallel, I know that angle 6 and angle 4, those are going to be supplementary to each other because they're same side interior angles. So I'm going to say that here. Angle 6 supplements angle 4. And that's if you've got, if K and M are parallel, then same side interior angles are supplementary. I'm just going to abbreviate that. All right, so let's move on to our next step. I know that angle 6 is supplementary to angle 12. I know angle 6 is also supplementary to angle 4. So that means that the two of them are going to be supplementary to each other. So that's what I'm going to say next. Angle 4 supplements angle 12. And that's using that congruent supplements theorem. And if you remember, that one says if two angles are supplementary to the same angle, then they are congruent to each other. Oh, well then that means I just messed that up. Sorry. What I meant to say is that they are congruent to each other. Sorry about that. I'm going to write that out. I'll pause this and write it out. So again, what that's the congruent supplement theorem says, if two angles are supplementary to the same angle, then they are congruent to each other. So that's why we were able to say that 4 and 12 were congruent to each other. All right, so let's look and see what that means for me. I know that angle 4 right here is congruent to angle 12. And in this relationship right here, those are corresponding angles. If we know corresponding angles are congruent, then we know those lines are going to be parallel. So my next step is that I can say A is parallel to B, and that's using the converse of the corresponding angle theorem. Basically, what that means is if you show corresponding angles are congruent, then you know the lines are parallel. All right, let's do another one. Okay, on this one, we're given that lines A and B are parallel to each other, and you're also given that lines K and M are parallel to each other. All right, so what that means to you is that these angles are going to have a relationship with each other because K and M are parallel. You also know these angles are going to have a relationship with each other because K and M are parallel. You're going to know that these angles have a relationship with each other because A and B are parallel. And then these angles have a relationship with each other because A and B are parallel. All right, so let's see what we're trying to prove. We're trying to prove that, let me write this in red, the angles 3 and angles 15 are congruent to each other. Now those particular angles don't really have a relationship with each other, so we're probably going to have to do something like the transitive property to get to where they end up being congruent to each other. All right, so knowing that K and M are parallel, I'm going to think about what angle 3 might be congruent to. So because lines K and M are parallel, I know that angle 3 will be congruent to angle 6. Those are alternate interior angles. So that's what I'm going to focus on first. Now I want to start with either angle 3 or 15. It doesn't matter which, but those are the angles that we are trying to get to, so I need to get those into my proof. All right, the reason why I know 3 and 6 are congruent to each other is because if K is parallel to M, then alternate interior angles are congruent. All right, next step. Now then I also know that angle 6 right here and angle 15 have a relationship with each other because A and B are parallel. So I'm going to say angle 6 is congruent to angle 15. And again, those angles are also alternate interior angles. So if lines A and B are parallel, then alternate interior angles are congruent. All right, lastly, I know 6 is congruent to 15. 6 is also congruent to 3. So that means 3 and 15 are congruent to each other using the transitive property. And we have proven what they ask us to prove, so we're done. All right, thanks, y'all.